Hello everyone, my name is Laminda and I will be doing the keyword enclosure project. Starting off, the whole goal of this project is to have a system a system of switches that control something called a piezo buzzer. And so the way the system should work is when you press each of these buttons, you should get a different tone that the piezo buzzer outputs. The piezo buzzer is a sort of an instrument that makes noise based on the frequencies that it receives. So each of these buttons has a specific frequency that it inputs into the piezo buzzer, and the piezo buzzer outputs a different noise depending on the frequency it receives. This project, the components that make up this project are, of course, the Arduino Uno, the breadboard. We have 4 switches here. We have 4 resistors, and we have the wiring. Once again, red wire is connected to the 5-volt pin, and the black wire is the ground pin to the ground rail, and this is also, of course, connected to the power rail. The system is sort of unique in that it uses something called a resistor ladder process, where all of the right terminals of the switches, as you can see, are connected to the AO pin using this long yellow wire. So you can sort of see that the yellow wire is connected to this wire, but then that's connected to the right terminal of the switch, this switch, then that's connected to the right terminal of this switch, and then this wire connects this switch to the right terminal of this switch, and then the right terminal of this switch is connected to this one, to this wire, and that's all connected to the AO pin. The left side of these switches are connected using this blue wire, and this is actually connected to the 5-volt wire and pin. So as you can see, the left terminal here is connected to this blue wire, and then it corresponds to this switch here, and then it kind of steps down as well. And then you have the resistors. Now this resistor ladder process is important because it creates sort of a voltage separator or divider, if you will. And it's important because the AO pin here can actually output a different voltage, and that's important because the voltage needs to be different. The voltage that's outputted to the buzzer needs to be different, and so that's why this process works. Okay, so going to the code, we have some where here this variable is getting set to a array where the first 2 numbers start with 2. The void setup. Once again, the void setup runs once at the beginning and only once. Then really quick, actually, the array here is preset by Tinkercad. It's a preset series of numbers that actually relate to each frequency of each button. The loop, the void loop, is the code that it will once again run continuously. And here we've defined key valve to equal analog read and the AO pin, and the AO pin is basically going to, whatever the value the AO pin holds is what's going to be what's actually going to be heard through the piezo buzzer. And those are the different types of frequencies. In this serial.print in key val, this will actually print the frequencies or the voltages here. So depending on whatever button you press, it'll actually output here. It'll monitor it'll print out the numbers. So here we have an if-else statement. So if the key value equals 1023, then the corresponding values the corresponding frequencies / sounds will be heard. And so here you can see that if the key value equals 1023, then you'll play the tone 8 and the notes 0. However, if this case is not met, then you'll go down to here, and this is the first switch right here. And if the frequency is greater than or equal to 990 and the key value is less than or equal to 1050, then you play this. However, if this case is not met, then you go down to this. And then if this case is not met, then you go down to this. And then if none of these cases are essentially met, then you'll go down to this, which is the no tone. So basically, if no button is pressed, then there should be no tone. So running the simulation now, you can see that each of these switches are going to output a different noise. And actually what's really cool is you can actually see them on this serial monitor. So if I go to switch 1, you'll see it's playing out 1023. You go to switch 2, 1001. You go to switch 3, and it's playing 512. And so if you notice, whenever I press the switches, the cases here are actually met. So when I press the first switch, you see the 1023, that's in between 990 and 1050, and so that's why it's playing this specific note here. When I go to the second switch, it's the same case. The third switch, you go, that's 512, right? 512 is going to be in between 505 and 515, and the last switch, that's going to be equal to 10, which actually meets this argument here, and it's going to play that corresponding tone. And when the switch is not pressed, it's playing 0, which means that it will play the no tone. And that's my project, the keyboard enclosure. Any feedback would be much appreciated. Thank you.